so cool for you both to be here. So let's do some intros. Parijat.
Hey everyone, my name is Parijat. I am a senior product manager with CloudFormation. Really excited to be here on the call again, Jillian. And nice to meet you again, Brian. We have worked together before with CloudFormation, so really excited to talk about all the amazing launches we are doing today. Arthur?
Yeah, hey everyone, I'm Arthur, a software developer in AWS CloudFormation, and yeah, really excited to demo this new intrinsic function.
This is awesome. I'm really excited for everyone here. And I know that we've got a lot of people who are new to AWS, maybe earlier on in their tech journey. So let's start off with what is CloudFormation?
I can take that, Jillian. So CloudFormation, basically the way we like to explain to our customers something called infrastructure as code. So what that really means is like today, if I'm, let's say, a customer and I have certain infrastructure on cloud, and I want to sort of replicate that and codify that in some sort of way so that I have a declarative language so that it's repeatable and predictable. And that's what CloudFormation really does, right? It allows you to like codify that idea of the cloud infrastructure that you have in your mind in a JSON and YAML templating language that you can deploy using our orchestration engine. And that's what like CloudFormation is. And then today's, I guess, the launch that we're doing is more around the CloudFormation templating language, things that we launched to enhance the authoring experience of the product. But I hope that kind of sort of answers your question, Jillian, about CloudFormation.
Awesome. I think it's one of the, like I said, I'm kind of a little bit biased because it's one of my favorite solutions in AWS. And like I said, I started out with it. So, one thing that I had to learn myself is like, what is infrastructure as code throughout my journey? So I'm gonna let you explain it. So for our audience that hasn't used infrastructure as code or actually don't know what that term is, can you talk a little bit about what that means?
I can do that, Brian. So today, like, let's say if I want to deploy an EC2 server, right? I can go to the console, I can click on it, or maybe perhaps I can directly like go to the EC2 APIs and like try to provision those kind of resources. But now let's say I do have like this entire infrastructure, right? That I had provisioned using ClickOps or some sort of like API hits. I want to replicate that, right? And I want to ensure like my team members across my entire organization are able to like replicate this in some shape or format. And that's what like infrastructure as code for a beginner person would be, right? Like I would want to author this template, right? I want to deploy an EC2 server and I maybe perhaps wants to create like a VPC network around it. And I want to attach like the data that we have to an S3 bucket and all of that. And I want to deploy this particular infrastructure in certain like steps, right? And that's kind of what it is, right? Like you come to the platform, right? You come to our CloudFormation service, right? And you author this template using JSON and YAML, and you define like, okay, these are the resources I need. This is how I need it, and that's what you would do. You would just go create a stack, which will then be the collection of all of these resources, and then you can like easily see it in your AWS environment. And yeah.
Awesome. So cool. One question I want to address in the chat that maybe applies to a couple people who joined us a little bit late. So if you missed any part of this episode, you can always go to the AWS Events YouTube channel, and there you can watch really this episode, which you'll definitely want to watch the one that we just had before. We had the NVIDIA folks on, really cool things. And Brian and I were talking about how we definitely want one of those for ourselves. So yes, back to really cool things with CloudFormation. So tell us a little bit more about this ForEach function.
I can do that, Julian. So before we get into the function, right, like let's look at the customer problem, right? For a long time, like what our customers have requested is that they wanted our CloudFormation language to be less verbose, more readable, and perhaps like having a more developer-friendly experience, right? So what we try to do is like we try to reach out to the community, and we first of all came up with this whole CloudFormation LanguageExtensions transform, and the transform really allowed us to like not just take feedback from the community on like things that we want to build. But it allowed us to focus on certain features such as the FN for each function, right? So what the looping function really does is that it allows you to create multiple instances of a particular object, right? And it allows you to do it with like the minimal lines of code. And for example, like if I use an example and we will run through like the demo where we show like certain examples around it. But if you, let's say, are trying to create 3 instances of EC2 instance, typically before using the for each function, what a customer would usually do is that they would copy the same lines of code, right, across their template. They will say, okay, EC2 1, EC2 2, EC2 3. But with the ForEach function, what you can do is you can just define all of that in the chunk of code under ForEach, and CloudFormation will go and then create all these EC2 instances for you, right? And that number can increase, right? You can have like 10 of them, 20 of them, and instead of like copy pasting and there's a benefit to all of this, right? The benefit being is if today it's not just you as an individual writing these codes, you might have peers who are like reviewing that code itself. And in those circumstances, like let's say you're trying to make some changes to the code, right? You're trying to change a particular configuration within that resource, right? And you have so many of these resources, changing that property itself and ensuring that that change has happened across your template, making sure you're making minimal errors. All of that kind of encapsulates in this like cute little experience that we have, which is like the FN for each function.
Yeah, I find this to be super interesting and super useful. And one of the most interesting things I found about this is like you guys are expanding the CloudFormation language. You're actually like adding these different functions and transforms and making it better for our customers. Can you talk a little bit about what that looks like going into the future?
Oh yeah, absolutely, Brian. So the language extension transform is something that allows us to like actively not just communicate, like, participate with the larger community, but also our AWS heroes. So within the things that we are currently working on, we have like RFCs open up for concepts such as variables, aliases, anchors. And what a customer can really do is that if you have certain feedbacks or suggestion on how we can improve the language, you can just participate with us in that open discussion itself, right? You could just have to go to the language extensions GitHub repository and create like an RFC, and you would see like members from our team engaging with you on over that particular forum, right? So I'll paste the link of the GitHub repository, but that's where like we currently engage, and we have about, I believe, 152 like feature requests on that repository. So there are a lot of them that we are currently like filtering. We are understanding how to make it better, like talking with our customer, just like understanding what is the first level principle of problem that we really want to solve. And yeah, that's kind of like the entire inspiration, right? Like having a more of an open format with the community on ways to actually improve our language.
Awesome.
Yeah, this is so cool. We've got some CloudFormation fans, infrastructure as code fans, and I'm sure they would all want to be able to actually see this in action. So can you show us?
Oh yeah, absolutely. Arthur, would you mind sharing your screen?
Yep.
Awesome. So I'll not like steal the entire thunder, and I'll probably let Arthur go walk us through the entire demo. But what we have here today is like the basic syntax of the FN for each. So few caveats, right? Like we'll not so much look into the syntax right now, because as we go through the example, the syntax starts to make more sense. But whenever you're declaring an FN for each function, what you're really doing is you need to have like a unique loop name for each function. And that what it allows us to do is it allows us to have like advanced use cases like nested for each loopings, as well as referring to the same loop across your template. But the main way our entire function is made is that if we look at line number 3, which is the collection or the list of strings, is basically the input that you have, right? Where you are defining, hey, loop across these kind of things, right? And we'll see an example of DynamoDB where we have different table names, and these table names will come into that particular list of strings, right? The other place where I would quickly look into, and then we'll just go through the demo and look at examples, is the output key. The output key is where you would put like the chunk of code that you want to replicate. It'll make sense when we look at the demo. So let's say in the case of DynamoDB table, if you have like the configuration of the DynamoDB resource that you want to like replicate, that aspect of the code would come like below the output key. But let's maybe perhaps skip the syntax, and I'll pass it on to Arthur. And Arthur, maybe you can like show us a few examples to the crowd.
Yeah, thanks, Parjat. So yeah, firstly, we'd want to go through an example of how we provision 10 DynamoDB tables, one before using FN for each and after using FN for each, and see the benefits of using FN for each. So in this first template here, we've defined 10 DynamoDB tables, each with the same properties, with the same configuration. So the attribute definitions, the key schema, and the provision throughput are the same throughout. The only thing that's unique across them is the table name, right? So if we look at the template itself, it's really verbose, about 132 lines. And just for 10 tables with the same configuration, only the table name is unique. So just looking at this, let's say we want to make a change. Let's say we want to create a new table. We would have to copy one of the tables and make sure we update the values to the right value that we want. And let's say we want to update our DynamoDB tables to be on demand. So let's say we want to do that for all our tables. Then we would have to go through each of the DynamoDB tables and set the billing mode to pay per request and remove the provision throughput property. So we would have to do this for each of our tables. So we can see that, one, how time consuming that could be, two, how error prone that could be if we miss one of the tables, as well as Parijat mentioned before, if someone were to review the changes in our infrastructure, that would also take a long time because there's a lot of places that we've changed our infrastructure. But now, how can we use FN ForEach to simplify this? So let's look at a template with FN ForEach. So within this template, from lines 12 to 23, it's almost the exact same as it was within the previous resource configuration. Other than the table name here, we use the ref intrinsic function on this string called table name, but we'll get more into that later. Let's first look at the entire template. So firstly, we have the transformed AWS language extension transform declared at the top. So again, this is required when using the FN ForEach intrinsic function. And we've also declared this comma delimited list parameter called table list, where by default, this would be a list of strings that contains table 1, table 2, up till table 10. And within the resources section, we've defined our FN ForEach intrinsic function with a unique loop name called tables. And we've defined the identifier, the first parameter, as a string called table name. And we've defined the collection here by using the ref intrinsic function on the table list parameter here. So this would resolve to, in the default case, a list of strings with table 1 up till table 10. And so we're going to be using the identifier here, table name, to get the current element that we're iterating over within the list. So here we've defined the output key, which is what's going to be merged to the resource level. So this is going to be the logical ID of our resource, where in this case, we have the prefix DynamoDB. And here we've used this $sign notation syntax to be able to get the current element. So this is the table name is once again the identifier. And by using the syntax, we're able to get the current element within the list. So for example, in the first iteration, this would resolve to table 1. So this would be DynamoDB table 1, DynamoDB table 2, and so on. And below that, we've defined the actual configuration of our DynamoDB resource, where the only thing that's different again from the previous example is the table name, where instead of a static string, we use this ref intrinsic function on the table name, our identifier, which would resolve to the current element. And yeah, just like that, we were able to define the FN ForEach intrinsic function, and we were able to define all our DynamoDB tables. And our template is much less verbose. And let's say if we want to make changes to our tables, for example, if we want to add a new table, we can modify the parameter by adding a new table reference. And let's say we want to make changes, like let's say we want to update our DynamoDB tables to be on demand. We can define the billing mode to be pay per request and remove the provision throughput reference. And just like that, if we call update stack, all our tables will be updated to be on demand. Yeah, we can see how simple that would be in terms of making the change itself, as well as reviewing the change if needed.
Awesome.
Yeah, it really is. I mean, I'm sure people would love to be able to understand, like we saw this as one example of iterating through a table, but can you iterate across other AWS services?
Yeah, it could be any type. So here we've declared the DynamoDB table, but you can define any type within the fragment, which is the third parameter of ForEach. And one note is you can also define multiple resource types within the fragment parameter. So we'll be showing an example of that later on. But you can have, for example, a DynamoDB table and the IAM policy for the DynamoDB tables that will be created.
Awesome. And I'm an old CloudFormation user. I hate to say it, but does this work with JSON also?
Yeah, it works with JSON as well.
Cool.
Nice. We've got a question in the chat from Archer Script. What does validation for this look like?
Validation in terms of
So
maybe Archer Script could elaborate, but go ahead.
If I'm assuming like and I'm just going to read into the question, right? If Archer, you're asking like, can we use like CloudFormation linter, which is a CFN lint for the ForEach to validate the syntax of my template? Then the answer is yes. You can use the existing linter tool to validate whether your template is syntactically correct or not, and you can deploy it as a CloudFormation like you can deploy this particular template, and what you can see is the entire unformatted version of the template as well within the deployment. So I hope that kind of answers the question.
Yeah, that was a good call out. Yeah, the Archer Script then said yes, validation of the syntax. And then there was another question from Scolator was asking, does this work in AWS SAM?
Yeah, it should work with AWS SAM.
All right, cool. I know we've got a lot of people, we've got new people to AWS, and I'm sure a lot of the people who have been using CloudFormation for a while are like, all right, this is cool, but I'd love to see something that's a little bit more advanced.
Oh yeah, I think Arthur has an amazing example for that, Jillian.
Awesome. Let's see it.
So let's say in this example that we had, the first example, we only modified only one of the properties was unique across our tables. Let's say multiple properties are unique. For example, with our previous example, let's say we want table 1 to actually have a read capacity unit of 10 instead. So I want 10 DynamoDB tables with almost the exact same configuration, but just one of the tables I want it to have a unique property value. So you can do that by leveraging the find and map intrinsic function. So let's look at an example with that. So within this template here, so again, we have everything is the same as the first example, except two things. Firstly, the mapping section here, and secondly, the definition of the read capacity units. So these two properties here. So let me first explain the mapping section here. So we have the map name, we've called it tables, which coincidentally matches with the unique loop name. And within the top level keys, we've defined the elements that are going to be appearing within our list. So in this case, table 1 and table 4. And for the second level key, we've defined the property that we'd want for these resources to have. In this case, table 1 would have a read capacity unit of 10. And so the mapping section contains the unique values. It's kind of an override behavior where whatever values we define in the mapping section is what's going to be unique across all the DynamoDB tables we'd be creating. And within the provision throughput, we've declared a find and map intrinsic function, which again, the map name would be tables, and the top level key would be a reference to the table name. So this would be the current element we're iterating over in the list. And the second level key would be the property value. And notice here, to the find and map intrinsic function, we've added this default value of 5. So this is a language enhancement that's added as part of this AWS LanguageExtensions transform. So basically what this means is, if we're able to find this combination within the mapping section, then it would use that value. For example, for table 1, the read capacity units would be set to 10. But if we're unable to find it there, then by default, we want to set the read capacity units to 5. And yeah, so using the find and map intrinsic function, we're able to define multiple different types of properties for the multiple tables that will be created.
So basically, Jillian, like imagine if you have, instead of having like homogeneous lines of code being run like replicated, you want to have like certain heterogeneous properties within that resource deployment. So it's like it's not purely like uniform, as in like every instant type looks the same, but there are like certain differentiation, right, between each of these instance types. So that's what like the functionality does, right? So you can use other intrinsic functions with your FN for each intrinsic function. So you're not really limited as a whole different like solution with this particular functionality.
This is so cool. Brian, I'm sure you're just like geeking out like right now. I know how obsessed you are with CloudFormation.
Yeah, absolutely. I mean, I work for AWS, but I still use CloudFormation for my daily job. And, I'm very interested in trying this myself.
So cool. I know we're pretty much close to time, so I'm sure a lot of people here will be really excited to get hands-on with this. So any place for where they could go to really get started?
I would just suggest going to the AWS public docs. We do like highlight a lot of these detailed examples through the AWS public docs. So there's like an FN for each, and under that we have like examples where you can use this functionality on like resources, outputs, resource properties, conditions, those sections of your template. I would also insist for everyone on the audience to go and visit our public discussions, which is the CloudFormation like language repo over GitHub. I'll paste both of the links after in this like chat, but then definitely insist that people go visit that and engage with us on like things that we can improve about the language and just get to know about the CloudFormation language roadmap in general. So yeah, those two are the places I would definitely request people go check it out. And of course, we have the LanguageExtensions transform, which does a bunch more things than the FN for each. So we have 2 JSON string, FN length, find and map enhancements, are other like functionalities that are provided through the extensions transform.
So cool. Arthur, anything else you'd like to add?
Yeah, I just wanted to maybe call out the 2 capabilities of using FN for each, which, so I briefly mentioned this before, but we're able to specify multiple resource types within the third parameter of FN for each. So in this case, I've defined a DynamoDB table as well as an IAM policy, where we'd use, in this case, we've used the getAt intrinsic function, and we've used the sub-intrinsic function within getAt, which is also a new capability as part of the AWS LanguageExtensions transform. And just like that, we're able to define the actions that can be performed on the DynamoDB tables that we create. So this is one possibility. And the other thing I wanted to call out was the ability to specify nested FN for each. So in this case, we have 2 FN for eaches, so one within the other. And yeah, so in this example, there's 3 applications we iterate over. And for each application, we want to create 10 tables. So we can easily do that by using nested for each.
So good.
And Jillian, like you can learn about all of this in the AWS blog that is published by one of our like developer advocates, Dan. And yeah, it talks a lot about all the things that you can do around like FN for each and find and map. So there is a blog we have, it will be there in the chat. My colleague will paste it there.
Perfect. Thank you so much. Thank you so much both for showing us this and telling us more about CloudFormation. I'm really excited for everyone to get started with it.
Yeah, thanks everyone.
Awesome.
So Brian, I'm sure that was your favorite segment, way to end a Friday, right, for you?
Absolutely. Totally informative. Like I'm literally gonna try to use this today and master by Monday.
I love it. Oh my God, so cool. I know for a lot of you who came in late, don't worry, you can always watch this entire episode that we did. We had a lot of really cool, we just saw CloudFormation, NVIDIA, the news from Jeff, all of that. You can be able to watch it on the AWS Events YouTube channel. And we also want to hear from you because we make this show to really be able to help you. So we have a survey that we actually do read. So please take a moment to fill it out. First 50 respondents will get $10 in AWS credits. Pretty exciting.
Absolutely. And you can use those credits on anything on AWS you want. So,
that's right.
Awesome. Yeah.
So cool. Wow. Well, this has been really great. Brian, anything that you want to just call out before we sign off for our Friday afternoon?
Yes, I do. I just want to say keep watching us for more cool content. We're always doing cool things like this. So if you want to learn about AI, if you want to learn about CloudFormation, or if you just want to talk to us, Julian and Brian, or see us.
Hey, if you just want to talk to us, I love it. So true. And I know there were some people who had some questions that came in the chat. If we didn't get to answer your question, please go to AWS Repost. It's a fantastic resource to be able to ask your questions, have them crowdsourced from the community. Also, some people from the service teams will go in and answer questions as well. So make sure you check that out if you didn't get your question answered.
Awesome.
Awesome. Well, I'm really excited for all of you to get started with a lot of the things that we learned today. Thank you so much for being here on AWS On Air, and we will see you all next Friday at the same time.